In match problem 1, we're given the function f of x equals x squared minus 6x plus 10. And the first thing we want to do is find which values of x correspond to horizontal tangent lines. So finding the slope of tangent lines always relates to finding the derivative at a given point. So we'll find the derivative of our function, and that's going to be 2x minus 6. So now to determine values of x where the tangent line is horizontal, that means our tangent line has a slope of 0. So we'll take our derivative function, set it equal to 0, and solve for x. In this case, that's going to give us x equals 6 halves, or positive 3. Now we want to understand or determine for which values of x our function is increasing or decreasing. So in part A, essentially what we found was a critical value, and in this case, our only critical value. So we want to construct a sign chart for the first derivative. At x equals 3, we're going to have a value of 0. So what we'll do is choose 2 test points on either side of that critical value to determine whether our function is increasing or decreasing in those ranges. So the first thing we'll do is evaluate our first derivative function at positive 2. That would give us negative 2. And evaluating our first derivative function excuse me, at 4 would give us positive 2. So when x equals 2, our derivative function is negative. When x equals 4, our derivative function is positive. So what this tells us is that our function is decreasing on negative infinity to 3 and increasing on 3 to infinity. So again, we were able to come up with this information without actually graphing our function with a graphing calculator, because we have those issues where if the window's set wrong on your graphing calculator, or if we have other information that the calculator's graph might hide from us, this is giving us the entire picture for all values of x, what the behavior of our function looks like. And then using this information, we can sketch a graph of our function. So in this case, we know that we have this critical value at 3. So we can go back to our original function and evaluate 3 squared minus 6 times 3 plus 10, which is going to give us 1. So the point of interest that we want to plot here is going to be the point 3, 1. So that's our critical value. And then without getting too specific about how our function is increasing, decreasing on either side, we know that as we go from 3 to infinity, our function is increasing. And as we go from negative infinity to 3, our function is decreasing. So we've got something that looks more or less like that. Now we could come up with the actual graph by plotting some more points or plugging this into a graphing calculator, but this lets us know what the general shape or behavior of that graph is. And what we have is our horizontal tangent line